Hi, I'm Professor Goins. Welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in college mathematics, go ahead and click the subscribe button because you're in the right spot. That said, let's get into the current video. I'm going to discuss the idea of a rational exponent. And so let me just first of all remind you, a rational number is a number of the form m over n, where m and n are integers and the denominator n is non-zero. So it's a fraction where the top is an integer and the bottom is a non-negative integer. Of course, for example, that would be things like 2/3, 4/5, 0, negative 3/2, so on and so forth. So not really doing those in any particular order, just showing you that the top is, it could be any integer, right? 0 is the same thing as 0 over 1 or 0 over 2, and the denominator is any non-negative or non-zero integer. Okay, so the idea is we want to figure out what would it mean to have something like this as an exponent. Well, first and foremost, let me take a look at a pretty basic computation. If I take 2 to the third power, okay, so 2 to the third power, of course, this is 8. Now, 2 to the third equals 8. I can equivalently write this information as the cube root of 8 is equal to 2. Now, let's use properties of exponents on this left-hand equation. And what I'm going to do is take both sides to the 1/3 power. So whatever that means to have an exponent of 1/3, well, it's a real number, and we know how to use properties of exponents to combine it on this side. Of course, power to a power you multiply. So 3 times 1/3 is 1, so this would be 2 to the first is equal to 8 to the 1/3. And of course, 2 to the first is the same thing as 2. Now, let's put together these two basic ideas right here. What I have is 8 to the 1/3, of course, is equal to 2. And this is the same thing as the cube root of 8. Okay. Now, this illustrates the basic idea that if my exponent has a denominator, that denominator is a radical. So let me write that out. Oops. Turn that down a little bit. For a positive integer n, and let's say a real number that is non-negative, a to the 1 over n, so in other words, remember that represents like a to a, say a to a half, a to a third, a to a fourth, a to a fifth, so on and so forth. This is the same thing as the nth root of a. Now I suppose we're also assuming that not only is it a positive integer, but also n is bigger than 1, because we don't have a radical with an index of 1. Okay, so exponent of 1/3 is the same thing as the cube root. Exponent of 1/2, so that would be a square root, because remember the square root has index 2. But let's do a few examples of that. All right. So for example, let's say I wanted to evaluate 4 to the 1/2 power. Okay, so 4 to the 1/2 power. According to the statement right here that we illustrated up above, the denominator is the index of the radical. So this would be a radical with index 2 of 4. And remember that a radical with index 2 simply means a square root. So the square root of 4 is 2. All right. Now, Here's something that always kind of causes confusion from students. If they see this equals this, let's say they missed a day of class or something, and they're looking at those two, they're like, oh, 4 times a half is equal to 2. And yes, 4 times a half is equal to 2. But in this case, this 1/2 is not multiplication. It's actually it's an exponent, which is related to multiplication, but it's not multiplication. And this denominator is the index of a radical. Let's look at a very similar example. 9 to the 1/2. All right, no, it's not 9/2. This would be the square root of 9, and of course the square root of 9 is 3. Okay. Now let's look at one more example before I show the general idea. Let's say I wanted to do 27 to the 1/3. Okay. 27 to the 1/3. Well, remember the 1/3 power is the same thing as a cube root. We saw this with this initial example. So that would be the cube root of 27. And of course, the cube root of 27 is 3. Okay. Now let's look at the most general example. Let's do an example of it first, and then I will illustrate the general idea. But let's say rather than having an exponent of 1/3, what if I had like an exponent of, say, 2/3? So let's do the previous example. Let's say 27 to the 2/3 power. Now, the property of exponents I'm going to use is actually illustrated over here. Remember, a power to a power we multiply? Well, that means I can rewrite 27 to the 2/3 as follows, keeping in mind that 2/3 can be written as 1/3 multiplied by 2. So I can think of what would I have, what two exponents would I have had to multiply together to get 2/3? Well, I could use 1/3 and 2. So therefore, 27 to the 2/3 is 27 to the 1/3 squared, right? Because power to a power I would multiply. Now what this says is let's do 27 to the 3rd first, right? Which would be the cube root of 27. So this would be the cube root of 27, and then that number squared. Cube root of 27, of course, is 3, and then 3 squared would be 9. Okay. So now let me show you the general statement, and then we will do another example of it. So in general, if I have a to the m over n, so in other words, I've got a rational exponent, this is the same thing as saying the nth root of a to the m, or the nth root of a to the m. Again, because multiplication is commutative, 2/3 is either 1/3 times 2 or 2 times 1/3. And so that means I can either do the radical first, exponent second, or exponent first, radical second. It doesn't really matter. Although in practice it might matter, because if I do a radical first, I'm going to reduce the number, and exponent first, I might increase the number. So let's go ahead and illustrate that with, again, another example. Let's say I wanted to evaluate 8 to the, we're going to do an exponent of 2/3. Let's just do 4. Let's do 4/3. Okay, so 8 to the 4/3. Now, if I was to use, say, this property here, where I convert a rational exponent to a radical, remember what I do is the denominator is the index, so that'd be the cube root of the base. Then I'm going to evaluate that to the 4th power. Now, what is the cube root of 8? Of course, that's 2. And then 2 to the 4th power would be 16. Okay. Now, we could equivalently say that this is the cube root of 8 to the 4th. So what is 8 to the 4th? So let's see, that would be 8 times 8 times 8 times 8. So that would be, then we'd have to figure out what is the cube root of 4,096. Of course, if I'm using a calculator, it's 16. But if we are trying to do this efficiently and we are not using a calculator, I think most people recognize the cube root of 8 rather than the cube root of 4,096, myself included. All right, so let's do one more example. Rational numbers could be negative, so let's see what happens if I have an exponent that is a negative rational. For example, let's say I wanted to do, let's say, 16 to the negative 3/4. All right, so 16 to the negative 3/4. Well, remember that to make a negative exponent positive, what I do is I flip the base and then change the exponent to a positive number. So in other words, 1 over 16 to the 3/4. All right, now within the denominator, I have a choice. I can either take 16 to the 3rd and then take the 4th root, or I could do the 4th root of 16 and then cube it. Well, certainly the 4th root of 16 produces a smaller number. So since we're doing it by hand, that's the way we'll do it. So this would be the 4th root of 16 to the 3rd power. And what is the 4th root of 16? Of course, that's 2. So I get 1 over 2 cubed, which is 1/8. Okay. So the thing to keep in mind is if you have a rational exponent, this is actually two separate operations. The numerator is an exponent and the denominator is a radical. So what you want to do is you want to break it up into those two operations. Generally speaking, the radical is the first thing that you should do, and then do the exponent second, because you'll be working with smaller numbers. With a calculator, it doesn't matter, of course. Anyway, thank you for watching, and please consider subscribing.